This video goes over section 4.3, which is titled Other Sampling Methods. So they go through 3 different sampling methods and then tell you their advantages and disadvantages. And there will be questions where it literally just asks you which of the following is an advantage to such and such of a sampling method. So those are important to have written down so that you can answer that question appropriately and easily. I'm going to just do one example where you're kind of classifying a situation, because that's all that really is assessed in this section. Is if I give you a scenario, can you classify it as one of the 3 sampling methods? Or if I give you a if I give you a scenario and I want it to be a specific sampling method, can you pick which example sampling method fits that scenario? And so there shouldn't really be any surprises going on unless it's just that the wording is weird and you can't make that connection. So for the start, the first sampling method is a stratified sampling method. A stratified sampling method combines a simple random sample from each stratum, and a stratum is a grouping of similar individuals to create a sample. So strata is just plural for stratum. And those are homogeneous, which means that they're similar again, right? So it's this grouping of similar individuals. For example, things like grade level, people that live in the same city, people in different age groups, right? So those would be similar individuals. They have something in common. Those create a stratum. The advantages to stratified random sampling are that it creates more precise estimates than a simple random sample of the same size, because you're ensuring that you're including people from different groups within your sample, as opposed to a simple random sample, you're picking from all the groups at once. Because of this, it reduces variability. So by ensuring that you're looking at the same number of people from each type of group, you're reducing that variability. The disadvantages to stratified random sampling is that a knowledge of the population is needed because you have to put them into these groups. So it is difficult when the population is very large to use stratified random sampling. The next one they talk about is systematic random sampling. This is when you randomly select one member of an ordered population, and it's important that it says that person or individual was randomly selected. And then they select every such and such a member until the desired sample is reached. So somehow they're randomly selecting one member. So whether that's using like a number generator, like we saw in simple random samples, or putting names in a hat and drawing a name, rolling a die, that kind of thing. Anything that's randomizing the selection of that first member is key. And then the rest is that K must be determined ahead of time. So if I'm picking every 10th person, I have to have decided that before I pick the first person. So those are some key parts to look into when you're identifying whether something is a systematic random sample. The advantages to this are that you can use them without a list of all population members, right? You don't need to know where the end point is because you're just picking every 10th person or whatever that number is that you choose. And so ultimately that means that it doesn't require finite population size, right? Because if I don't have a list of everybody, I don't need to know exactly how many members are in the population, nor do I have to have a specific set number of the population. I can assume that my population is infinite. The disadvantage to this is that because of that not requirement of a finite population size, is that I don't know everything about the entire population. So if there's any patterns or clumps of differences within that population, we might not notice. So there might be strata that we should have taken into account and maybe did a different sampling method, but we can't tell because we're assuming this population size is infinite. The last one that they talked about here was cluster sampling. And so cluster sampling uses grouping like stratified does, but the difference is that the clusters then are not similar individuals. So it selects a sample by randomly choosing clusters and including every member of the cluster in the sample. So in stratified, I have strata. Remember, strata is people who have a similarity. In a cluster sampling, I have a cluster. A cluster is a small scale replica of the population. So that means that they are different. One key too is that they're located near each other in this, which helps create some of the advantages. So an example of this would be like if I want to identify something about high school students, each high school individually would be considered a cluster. Versus if I was looking at a stratified sample, I would look at grade levels within a high school and pull a simple random sample out of those, as opposed to taking an entire high school here, an entire high school there, and an entire high school there to create a cluster sample. So an advantage to this is that members of the sample are near each other. So when I'm collecting this data, I'm saving time and money because I'm just going to one place to collect a lot of data, and then I'm going to the next place to collect from that next cluster. A disadvantage is that sometimes it's not easy to break down a population into small scale replicas. So this high school example is an easy one. We could talk about maybe like a city, right? If we're looking at a city in a state, but there's a lot of variability there in general. And so clusters can be difficult to make. So in the example, we're talking about a band director who's trying to decide what music to play for a halftime show. She surveys the marching band to get their opinions about which music they would prefer. Identify each of the following sampling techniques. So if I have a computer randomly sort the band members, so the computer is randomizing the data and then I'm selecting the first 30, this is actually a simple random sample. Right, I took everybody in my population, which was all of the members of the band. I randomized them using a computer, and then I just picked the first 30. The next one, it says I randomly select 2 students from each type of instrument. So trumpet, sax, clarinet, etc. So if I think about that, I'm doing a group. So I know it's either going to be a cluster sample or a stratified sample. So what I'm looking at is, are these strata or are they clusters? So are all the members in the group similar or all the members in the group different? And so since they all played the same instrument, that means they're similar. Which means that this is a stratified random sample. The next one, I'm going to randomly draw a student's name to start with, and then survey every 5th student. The number was determined ahead of time after that. So these are the key components to a systematic random sample. In order for it to be systematic, I have to randomly somehow select the first person, and then I have to take every such and such a number that was determined ahead of time. So it's important that the sampling method indicates those 2 things in order for it to be systematic. If it just says start with student A and then pick every 3rd member, that would not be a systematic because it doesn't indicate that they were randomly chosen at the beginning and that the number was determined ahead of time. Finally, if I randomly pick a year of students, freshman, sophomore, or junior, and survey every student in the selected group, this sampling method does not fit any of our sampling methods. So if we look at this, these are homogeneous groups, meaning they're strata, okay? But when I'm looking for a stratified sample, I'm not serving every member, right? So when I'm serving every member, it should be a cluster. So these should be groups of students that don't have something in common. And so this is actually none of the sampling methods that we've talked about here. Okay, so again, we talked about a disadvantage to cluster is that it's hard to create a cluster sample. So if I think about the situation of a band, right? I guess if I were to take one member of every maybe type of instrument, so one person that plays each instrument, make that a cluster. One person that plays each instrument makes that a cluster. I could group that way and then pull clusters to create a cluster sample. But this problem doesn't give us an example of a cluster. Okay, so remember that you want to make sure you have the advantage and the disadvantages listed for each of the 3 sampling methods on your notes, because there are quiz questions that just ask you which of the following is an advantage to this.